Solutions of model equations and trajectories in the configuration space. Assuming that t equals lambda tau, lambda equals 2a1 k12b, we have transformed equations 4, 5, to non-dimensional system, where we solved numerically equations 6, 7, with the help of the maple. To construct corresponding graphs, we used the values of the coefficients I, f, K12 and parameters a1, a2, b, a that are presented in tables 4 to 5. Estimated values of parameters b01, k01, I12 are in table 6. Coefficient I, Yakushevich et al., 2005. Parameters a1, a2, b and coefficients, f and k12, Yakushevich et al., 2005, 2009. Parameters b01, k01, I12. Graphs of the solutions of equations 6-7, obtained for AT and for GC base pairs and for 3 cases: A. Ideal case when effects of dissipation and external fields are neglected. B. Non-ideal case when effects of dissipation are taken into account but effects of external fields are neglected. C. Non-ideal case when both effects of dissipation and effects of external fields are taken into account, are presented in Figure 22. The trajectories of the considered dynamical system are presented in Figure 23. When constructing the graphs of the solutions and trajectories, we used initial conditions, which are close to the point 0.2753, 0.3347, 0.0, 0.0, in the phase space, and we shall show in the next section that this point is stable in the case of at base pair. Summarizing the results presented in Figure 22-23, we can state that effects of dissipation lead to decreasing the amplitudes of base oscillations. Effects of external field lead to displacement of the equilibrium positions, displacement in the case of GC base being less than displacement in the case of at base pair. So, we can state that polynucleotide chains saturated by at base pairs are more sensitive to the action of external field than the chains saturated by GC base pairs. Solutions of equations 4-5 obtained for AD and GC oscillating base pairs and for 3 different cases: A equals 0, F equals 0, B 0, F equals 0, C 0, F 0. Trajectories in the configuration space, phi1, phi2, calculated for AT and GC oscillating base pairs and for 3 different cases: A equals 0, F equals 0, B 0, F equals 0, C 0, F 0.